the proof of convergence of Nesterov accelerated gradient descent algorithm is a bit complicated. So I'll first introduce two very important ingredients for this proof, and then complete the proof using the two ingredients. And then I'll provide detailed proof for each ingredient. Okay. To this aim, I'll first introduce quadratic approximation. So this will give you kind of potential function for analyzing the convergence. So let's say the pi 0 is equal to fx0 plus alpha over 2 times x minus x0 norm square. So what does this mean? So it's centered at x0, and starting from fx0, the real function value, and then approximate real fx function using quadratic function, of which curvature defined with alpha. Okay, so this is very simple quadratic function. This is a bias term. Bias comes from the real function value f0, and then centered at x0 and increase with speed of alpha over 2 with curvature of alpha. And then we recursively define pi s plus 1. Pi s plus 1 defined from pi s and the linear approximation of point at xs. Okay, so this is kind of linear combination between the pi s and the tangent line function at point xs. And plus, since we know the f function is alpha strongly convex, we approximate the location when you have real function f. When you know the reference location xs, you can approximate this function f using the tangent function plus alpha over 2 times x minus xs norm square. That basically lower bounding the original function f. Why? F is alpha strongly convex because, okay? And then we simply interpolate the pi s potential function and the new approximate at point xs with the reference point xs. Right. So every time pi s plus 1x for all s is a fine function plus alpha over 2 times x minus vt norm square with some vt. We can very easily compute the vt, by the way. So now I will introduce two very important properties of the potential function pi. The pi t x minus fx is always lower bounded by, upper bounded by, 1 minus 1 over square root kappa per 2t times pi 0 minus fx0. Okay. From the definition of pi sx, we know that pi s plus 1x minus fx is equal to this. I just rewrite the pi s plus 1x from the definition of pi s plus 1x. Okay, and then from the alpha strongly convexity of function f, we know that this term is negative. So we have pi s plus 1x minus fx is less than or equal to 1 minus 1 over square root kappa times pi sx minus fx. So when you iteratively decrease the value s, then we have fact 1. The second fact for the pi function is this. Fys always less than or equal to the minimum value of pi sx. This is a little bit tricky to show, so I will provide a detailed proof from the next slide. Okay, so when you have fact 1 and fact 2, from the two facts, we can conclude the convergence speed. Fit minus fx star is less than or equal to pi t x star minus fx star. Why? From the fact 2. And from fact 1, we have 1 minus 1 over square root kappa power to t times pi 0 x star minus fx star. And from the definition of pi 0 x star, we have this. It comes from the definition of pi x 0. Right? And so we have this. This comes from the beta smoothness of function f. Okay?